Hello everybody, and welcome back to another Flow video. This is Jacob Tucker. I tried to record this video yesterday. Yesterday was 420, but due to some unfortunate circumstances, I was not able to complete that video even though I tried. And so, yeah, we're back today. First of all, I want to give a massive shout out to Greg for helping me so much and helping me to learn about account proofs and the new FCL updates and all this kind of stuff. And everything you're going to see today in this video is thanks to Greg. So thank you, Greg, for helping me out. And yeah, so let's just dive right into it. So as some of you may know, FCL 1.0 is going to be coming out in the next couple days/weeks. I actually have the GitHub pulled up right here so we can take a look at it. So yeah, we're going to be working a lot with the new FCL. And one of the changes that was made to FCL was how account proofs work. Now, if you don't know what account proofs are, that's totally fine. I'm going to be sort of explaining that throughout this video, but I wanted to make this video to show you how to use account proofs using the new FCL, and it's actually really cool. So yeah, let's just dive right into it. So if you want to, I'm going to leave this link in the description if you want to take a look at the new FCL. But we're going to be going over this part, which is the account proof service enhancement. In a different video, I'll do the rest of the FCL updates. But yeah, this basically is a short little thing describing how to update your application to use account proofs. And then there's also this other this other link I have right here that's a sort of like a longer README on how to totally configure your application for account proofing. But before we do any of that, I sort of just want to walk through a diagram together explaining why you would even use account proofs and what they are. So put simply, an account proof is basically a way for you to say that you have ownership over an account. More in the more technical terms, it's basically like an object that has some signatures inside of it. And those signatures can prove that they were signed by you, or that, you actually are currently holding or owning this account. And so one way that you can actually use this in your applications, besides just verifying you own an account, is to get access to some private information from a website. So if you think about Instagram, for example, right, when you're on Instagram, only you have access to like your favorited list, right? And that's because you logged into Instagram, and so you should be able to see your favorited whatever. Or when you make one of your Instagram posts archived, only you can see those posts, right? Not everyone else can see them. So when we're dealing with sort of the blockchain world or Web3 world, we want to basically prove to someone or prove to a website or backend that we own a specific account, so we can get access to things like friends lists and private information that only we should be able to see because we own the account, right? Now, one little nuance there is that we're not logging in with a username and password. We're logging in with an account with a blockchain address. And so we need a way for us to prove that we actually own that account. And that's where account proofs come in. So this is a very simple diagram where there's a person at their computer. They go to log into a website with their blockchain address, not a username and password, but with their blockchain account. And then the website does some fancy stuff and gives them access to whatever that may be. And this is done with account proofs. Now down here, I sort of have like a longer description of how this is actually done. And so we're going to walk through this together. So what actually happens is, this is just a diagram. So this diagram we're viewing right here, this is exactly what the code's going to look like that we're going to develop in a few minutes here. And if you want to skip this all, you can, but I think it's helpful. So a person is at their computer. They click a login button on a website, right? So it goes to that website, and the website, requests something called a nonce from a server or backend. Now, a nonce is really just it's a 32 bytes hex string. So it's basically just a bunch of random numbers and letters. And you need to do this because in order to actually generate an account proof, you need to provide a nonce to the FCL config. So you ask for a nonce from the server backend. It will return a nonce. And then the website will store a user object with the account proof inside of it. So, now there is a user object that exists, inside, the front end that you can use to pass in an account proof to prove that you actually own the account, right? So that's just when you click login. Now, actually, why don't we even walk through this process together? I believe I have this running in my terminal. I do. So why don't so let me show you what this looks like. So on this website, right, I'm going to click on login. It's going to come up with a prompt here, right? So when I just logged in, you'll notice on the back end, it pinged the back end, right? And this is just a console log I had. So it pings the back end, and here is the nonce that gets generated, right? Now, when I go back to the site and I click on block to again, and then now we're going to complete this next step. So this next step says, that was all this right here. So the user clicked login, the website talked to the server and backend, got a nonce, and that's what was printed at the console here. And then the website now stores the user object. Now, the second part is going to be the person is at their computer. The user selects wallet and confirms, right? So I just selected my wallet and now I'm about to press confirm. And so what's going to happen is the website's going to send the account proof to the backend that got stored right here. The server backend is going to check if the nonce exists. So what you have to do is on the backend's going to store, right? When it asks for a nonce, the backend's going to store the nonce here and then return it. I should probably add the diagram. So it's going to, store the nonce, and then return it to the front end, right? And so then the backend's going to check if the nonce in the account proof exists, and then if it does, delete it, and then check the account proof is actually valid with FCL, and then give access to the user. Or if the nonce doesn't exist, then it's not valid. This whole thing is not valid. And so just to give you a little bit more context for why we're sending the account proof here, the account proof is just an object that contains signatures proving that we own the account. And these signatures are going to be used to check the account proof with FCL right here. Oops. To actually check the account proof. And then also this nonce is in here as well. So this is going to be used for these two steps right here. So that's just to help you out understand. And I'm going to post this as well if you want to just keep looking at it. All right. So when I click confirm here, it's going to verify me, and Next.js is weird. So if I let me just do this again. If I click on confirm, it's going to give me a anyway, it'll verify us here, but I changed some stuff around. So anyway, let's ignore all that. But what would happen is I would click confirm, and then it would say verified true. Okay, so that's what we're gonna build today. I know this was a little weird, but anyway. Yeah, okay, so let's just dive right into it. So I have my notes up on my left screen, and this is going to be my real screen on what I'm looking at right now. And all that's here is actually, let me just delete some things here so that it's completely new. So this is just an empty, Next.js project. There's literally nothing new here. The only thing I did was I got rid of some boilerplate stuff inside the index.js. So completely boilerplate. There's nothing else I added. Just create a new Next.js app, and you should be good to go. And I'll post all this code on GitHub as well. Okay, so the first thing we want to do is we want to just create a login button, right? We want to just be able to log in. So actually, before we even do that, one thing I forgot to mention is in your package.json, you want to install two things. One, @onflow/FCL, and you want to install this specific version. It's not actually, at the time of this video, it's not actually officially out, but it will be at some time. So you want to install this version, and then install the crypto library as well. And you can do that just in your terminal by doing npm install @onflow/FCL and crypto. Or I think a better way to do it would just be to copy and paste these two things in your package.json and then run npm install, and it will install those two dependencies so that you make sure you have the right versions. Okay. With that being said, wow, there's a lot of rambling. Let's actually go ahead and make a login button. So we can make a button here that says login. And we actually need to make a function that's going to log us in. So why don't we make a new directory here called utils, and we're going to make inside here a login .js, and inside here we're just going to make a little function to log us in. So let's say export function. Let me just look at my notes over here. So export function or export async function login. And this is just going to do very simple things. We're just going to say await FCL.authenticate. Oh, wow. That is quite bizarre. I don't know why I did that. But let's import all as FCL from @onflow/FCL. And then we're going to say await FCL.authenticate, just like that. And that should be good to go. So what we can do is now we can actually import. Let's import. Actually, I think it'll auto import if I just do this. OnClick equals login. Oh, no, it doesn't. Okay. Let's import login from the utils. And now we should have a button where we can press it and it will log us in. So, with FCL, we just click on, we just do await FCL.authenticate and it'll log us in. So let's go ahead and do that. This is not the one that I want. So let me stop this and new version that we have. And hopefully all will go well. So let's wait for it for a sec. Okay, and refresh the page. And so now we just, why is it still doing that? What? Oh, did I not? Oh, okay, I guess I didn't officially stop that. All right, here we go, perfect. We have a little login button, and when we click it, it's going to give us an error, right? And why is this? Well, it's because we haven't actually configured our FCL config. So, with any FCL app, we've probably done this a billion times, but we need to actually configure our config, or FCL. So let's make a new folder called flow, and inside we'll do a config.js. And in here, we're just going to configure the config, right? So import all as FCL from @onflow/FCL. And we need to point our application to testnet and Blockto as well. So let's go ahead and do that. So fcl.config, we're going to put some things in here. So .put, first thing we're going to put is, that we want to actually point your application to testnet. So let's do access node.api. And this is going to be a little different than usual. It's going to be HTTPS and then REST testnet. And this is just because the new FCL uses a different, route to actually access testnet. And then we're going to also put discovery.wallet. And this is going to allow us to actually use Blockto. So HTTPS, and I'm just going to copy and paste the rest of this just because it's a little annoying. Instead, make sure I don't mess up. But fcldiscovery.onflow.org/testnet/authn, and this will allow us to use Blockto. So this, points us to testnet. This allows us to use Blockto wallet, right? It's cool. And then that's all fine and dandy. So once we have that, that's great. Now we're gonna have to add a couple other things. One thing we're gonna have to add is this something called. Actually, you know what? Why don't we go ahead and test this right now? So let me just stop this and rerun it for a sec. All right, so let's refresh the page. We can log in, and it's still giving us a problem. I believe that's because I actually have to import inside here. Import config. Oh, can I do this? No. Config. How do I import? Oh, I think I can just do this, right? Like import flow/config.js. Okay, perfect. Now if I import that, it should have the configuration set in our Next.js app, which it does. And so you can see now that if I click on, Blockto, and it's going to allow me to authenticate in the whole thing, right? But we're not actually storing the user anywhere. So, when we log in, we want to be able to store the user somewhere so that we can, be able to access information about our user. So what we can do is inside our index.js, let's add a piece of state. So const user, that user equals use state. I don't know why it always does this. Okay, from React, and then we're going to just leave it empty. And then what we're also going to add is a use effect here. Let's just add a use effect. And we're going to add a little thingy in here to keep track of the user when we actually log in. So to actually set it. This is going to be FCL.current user. Oh my God, why does it keep doing that? Nope, don't want that. Come on. That current user. .subscribe. And we're going to pass in set user here. Perfect. Let's get rid of this because I hate it so much. All right. And this is going to run only when the page refreshes. Cool. So now we're going to be able to actually store our user inside this user object. And so what we can do just for fun is if we want to, we can, just display the user here. So let's just go ahead and display the user. The way we can do that is just doing, actually, I'll put it in like a pre-tag here. So I'm going to display a JSON.stringify just so that we can actually see the user object on the screen, like this, and then null2. And this will just allow us, again, just to view the user on the screen. So what have I done wrong here? Oh, of course, I need to wrap this all in a div so that it's only returning one component. Okay, now let's reformat. Boom. So if we go to our web page, it's going to say FCL is not defined, and that's because I have to import all as FCL from @onflow/FCL. Cool. So boom, here's our user object because we logged in, right? So super cool. We can click login again, but why don't we just make another button called log out just so we can, use this for our sake. So button, let's do on click is going to be a simple function that's going to run fcl.onAuthenticate, and this will just allow us to log out. All right, so if we go down here and click on log out, you'll see the user is empty. But if we go ahead and click login, and with Blockto, and we click confirm, this is our user object. Now, one thing I want to point out that's actually pretty interesting is that in previous versions of FCL, you would notice that the user has a account proof inside its services array. However, now it doesn't do that by default. So, your user object will not have an account proof inside of it unless you actually specifically configure that in your flow config. So let's go ahead and do that together. So inside our config, we need to add one more thing. Oh, and for the record, if you want to follow along in notes, this is all, where is this? Where can we find this? I believe you'd be able to find, yeah, so right here. So when it talks about the FCL.AccountProof.resolver, and I believe it talks about the resolver in these notes as well. Yeah, so right here, it talks about this resolver. So if you want to follow along in notes, you can just go to this link right here. Again, I'll put this all in the description, but let's do it together in video format. So one thing we have to add here is, let me just do another dot put here. We have to add this thing called FCL.AccountProof.resolver, and we have to pass in a resolver function. Now this resolver function, we're going to define at the top, const resolver equals async function, like that. And inside here, we're going to return a nonce and a app identifier. We have to return two things: an app identifier, and this is going to be like the name of our application. So let's just call it like Jacob Rocks, okay? Let's just call it that. And then the nonce has to be a random 32 bit whatever. So in order to do that, let's actually just use the random one that was generated over here. I'm just literally just using any random string right now. And then at the end of this video, we're going to figure out how to create a new one for every single user. But for now, let's just do an app identifier and a nonce like this. And so then if we pass in the resolver here, what's going to happen is it's going to give us an account proof object now. So let's log out. Let's log in. Let's click confirm. And so now we should be able to see an account proof object get generated right here. Boom. So here is our account proof object. And yeah, that's super cool, right? Because now we can actually verify with this account proof that we actually own this account. Because you can see there's stored signatures inside of it as well. So let's go ahead and do that. So now that we have this configured, what we can do is when we're actually logging in and we do await FCL.authenticate, we can prove to our user that prove to the website that we actually own this account and verify it. So how do we actually verify it? Well, let's say, let's actually store this authentication in res, and res is going to be like our user object. And so what we want to do is we want to access this object, because we're going to pass that in to a FCL helper function called verify account proof that's going to help us do all this fun stuff. So let me look at my notes again. Okay, cool. So one thing we're going to do is we're going to go to our login and we're going to say, const account proof service equals res.services.find service service.type equals, and then hold on, account proof. All right, just like that. And then we can, close off that line. And now, this is our account proof now. So why don't we actually go ahead and console.log account proof service. All it's going to be is it's just going to be this object right here. So we just search for this object inside the user. So let's go ahead and log out. And now when we log in, let's clear everything. We log in, click on Blockto, and we actually click confirm. Boom, here's our account proof object right here that I showed you was also on the left-hand side here. So right here. Awesome. So now let's actually use this account proof data to verify that we actually own this account. So let's just say if account proof service, so if it was configured, again, we want to account for the case that this was not passed into the config for some reason. But if this is not null, then what we can do is we can say, I'm looking at my notes, we can say, const verified equals await FCL.apputils, which is new to the new FCL, that verify account proof. And then here we have to pass in a couple things. One is the app identifier. So the app identifier is Jacob Rocks. So let's put Jacob Rocks. And the second thing is the account proof data. So it's this right here. So account proof.data. Let's do it together. So account proof service.data. And then what we can do is we can console.log verified to see if we actually own this account. So let's refresh the page. Let's log out. Let's log back in. Blockto. And confirm. And we get a massive error. Oh, yeah. And I believe the reason for this error... Yeah, okay. I believe the reason for this error is because we also have to configure one more thing. So the one thing I forgot is inside our configuration, we have to configure env to look at testnet. And the reason for this is because, and this might be changed in the future after talking to Greg about it. But the reason we have to put this is because, sorry, I'm blanking for a second. It's because when you use verify account proof, so right here, verify account proof, in this code, it's actually needing to look at whether or not it's emulator, testnet, or mainnet. And so when you put this, it'll know it has to verify against testnet. So if we try this again, log in, let's clear all this again, blockdo, and confirm, then we can see it prints true, right? So we actually own this account. Yay. So it successfully went through. We owned this account. Now keep in mind that, this app identifier has to be like it has to be the same one as the one that you configured in your resolver function. And so it's, just so that, it's both, sides of the spectrum are on the same page. Now, what we did here was this was all in our front end, right? So there's not much use to this. I just wanted to show you quickly this in case you just wanted to figure out how to verify an account proof. You just need to, use fcl.apputils.verify account proof, pass in the app identifier and the account proof service. Now what we're going to do in the rest of the video is I'm going to show you how to actually use this workflow that I showed you in Excalidraw to have a, user, doing this whole process, right? Where the backend gives information back to the user. Okay. So let's go ahead and abstract this a little bit to also use a backend. So what we can do is we can go to our pages API, and I'm going to delete this hello.js, and instead I'm going to add a new one called generate.js. Now what generate.js is going to do is it's going to generate a new nonce for every time a new user logs in. And the reason for that is because in our config resolver here, we don't want to use the same nonce for everybody because then, people could just, pass in a wrong nonce. So we want to give each user a new nonce, and then that way when they go to verify, we can check if the server is actually the one that generated that nonce or not, right? So when we go to log in here, let's do this instead. Let's say const response. We're going to ping our generate on the back end, which is going to create the nonce for us. Say await fetch /API /generate, okay, and then we're going to say const nonce. We're gonna write this code in the backend in a second here. Await response.json, and then this is going to be our nonce that we use, and so we can actually pass that in right here, and say nonce is going to be the nonce, but ES6 syntax we can just write nonce here. Okay, awesome. So now we actually need to write the code that's going to generate the nonce for us and pass it to our resolver here, which we're going to do in the generate file right here. So just to have some boilerplate Next.js, stuff, we need a handler here. And so now we're going to generate the nonce. Okay, cool. So let's say const nonce equals, and we're going to use the crypto library that we installed to do that. So let's go ahead and import crypto from crypto. All right. Say const nonce equals crypto dot random bytes, and we're going to we need 32 byte minimum, so let's just do 32 bytes. That toString, and it's going to be a hex string. Cool. And then what we can do is just res.status. We're going to return this to the user 200.json, and we're going to pass through the nonce. Now, one thing we also have to do in addition to this is store this nonce somewhere so that when we go and actually click confirm, it's going to send the account proof back to the backend and check that nonce was actually created by this backend. So we need to store this somewhere. So in order to do that, I have a file written already. I'm not going to write this with you guys because I think it's just a waste of time. It doesn't really have to do with this video. However, I'm creating a file called storage.js that has a nonces array and a function to add to that array, check if a nonce is in that array, or remove that a nonce from the array. So with that being said, let's just go ahead and use these in our generate file here. So in generate, we can import add nonces or add nonce from /storage.js. So what we can do here is right here, we can just say add nonce and then the nonce that we just added. And that will store it in our backend. Now, in a real life scenario, you would never want to use this, right? You would probably want to have some database somewhere where you're storing the nonces. But I'm just using a local file here because screw it, whatever, right? It's okay. So we add the nonce here, and then perfect. And then when we go back to our front end in the config, you know, the resolver is going to use that nonce to pass in, right? So let's just go ahead and see what happens. So let's log out here, and let's log in, and we go block.do, and we're gonna click confirm. And so let's just see the nonce, what nonce was generated, right? So account proof. So okay, here's the random nonce that generated. Awesome. And what we can do is actually, let's just go ahead and add some console logs to make it more helpful. So when we add the nonce here, inside of our storage, let's get rid of some of these extra console logs here. Let's just console.log nonces after adding. Nonces after adding. Nonces. Okay. And then when we, you know, remove, let's just say nonces after removing, and we'll log it again, just that we can more easily keep track of what nonces we're storing, right? So log out, and we should be able to see that on our backend here. So log in, block.do, and confirm, and it says nonces after adding, boom, right? So this is the nonces after adding. Now, one thing we have to do is that when we actually now, so that's just the resolving, right? But we actually, when we click on login right here, we need to verify the account proof exists and that the nonce is correct, right? And here, we have to send the account proof to the backend. So not just check it here, but send it to the backend. And we have to check if the nonce exists. If it does, delete it. And then 3, check the account proof with FCL. So what we're going to do is, in the login file, we're going to say if account proof service, we're going to send this account proof data to the backend to check it on the backend. So const response equals await fetch, and we're gonna have to write this endpoint in a second here. Verify, right? And we're going to send some data to this verify endpoint. So it's going to be a post method because we're sending data. Okay. The headers are, let me just copy and paste this because I don't know anything about headers, but whatever. You have to put this. And then the last one is the body. So what are we going to actually send to the backend? So json.stringify the account proof service.data so that we can check that data on the backend, okay? And then we're just going to say, you know, the backend's going to verify us, and then we're just going to say const verified equals await response.json, just so we can know what the backend said to us, and then console.log verified. Okay, cool. So then we can move all this code into the backend. All right, so we're going to move all this code then into the back, and this is await fetch. All right, so then on our backend, let's get rid of this console log. We need to make a new endpoint called verify. So verify.js. And again, let's just copy and paste let's just paste some of the code that we had before. But let's go ahead and let me look at my notes here. So again, just some basic Next.js stuff, right? This is just for the endpoint. We're going to import all as FCL from @onflow/FCL. And then we're going to also need to import, okay, yeah, so we'll do this for now. Okay, so first of all, we're going to get the data. So const data equals request.body. And what this is actually, you know, let's just console.log it. Let's console.log the data, and we'll just get rid of this for now. So let's see what this looks like, okay? So let's go back to our front end here. Let's log out. Let's log in. block.do. Let's click confirm. And so on our back end, we should see some data. So here's the data we just logged, right? And it's the account proof that we sent through. Because if we go to login, you know, we sent the account proof data through in the body right here. Then our verify function, we're just logging the body right here, which is this object. Now, what is the first step that we saw in our diagram? Check if the nonce exists. So the nonce that was passed through is in this account proof. It's right here. So let's get the nonce together. So let's just say const nonce equals data.nonce. Okay. And we're going to make sure that it exists. And we already wrote that function in storage.js, check if the nonce exists on the backend or not. And again, you would do this with a database, but you get the point. So if check nonce, it's going to auto import it. Love that. If the nonce does not exist, then return res.status 200 and .json, and we're going to say verified is false. So you did not verify because you know, the nonce was not valid or whatever. Okay. Cool. Then otherwise, so what's the next step? Otherwise, if yes, delete it. Okay, so if it does exist, then we're going to remove nonce. So remove it. Okay, and then we're going to what's the next step? Then check the account proof with FCL, which is exactly what we did already. We already wrote this code. So let's go ahead and add this code back in. Okay. And we remember to use the same app identifier. And then instead of account proof service at data, it's just data because that's what we passed into our backend. Okay. Then we're going to do res.status 200.json, and we're going to return verified here. So it's going to return true if this returned true, or false if this returned false. Okay. So with that being said, and then it's going to return that here, and then we're going to log whether or not it was verified. So let's try it together. So let's go back, log out, log in with Blockto. We're going to click on confirm, and it logs false. So why did it log false? Let's see. So nonsense after adding. Oh, it's because, okay. So there's this weird thing. I'm not going to cover this in this video, but there's this thing with Next.js where every time that you ping your backend for the first time, it recompiles. And so this is why using a local storage isn't going to work for your nonsense. It's because it's going to recompile and reset the array. But without recompiling, if we just go ahead and log out and relog back in, without it recompiling this time, it's going to actually, oh, well, there's still a problem. Okay, so why is there a problem? Okay, so I have no idea what happened. I think it's just Next.js being weird. And again, that's a problem for a different time. However, if we click login here, click on Blockto, and then we click on confirm, look what's going to happen. It's going to print verified true. So that means that not only was the nonce that was passed through did it exist, but our account proof was also correct. So just to take a quick step back here for a second, why do we really do this? Well, the reason we did this is because now, when we printed verified true here, this is coming from our backend, right? And our login function, our backend told us that we're okay now. So, theoretically, what would also happen on your website, if you had like an Instagram clone or some other piece of data where you wanted to give the user access to some stuff now, you would send that along this route, right? So you would return that from your backend here, and now on the front end, you could display some information. So, just to like reiterate that point, if you, in your verify.js function, right here, you would say like, if, the user is verified, then, return, return some private information only for that user, like a friends list or, contact info, stuff like that, right? But we're not doing that in this case. In this case, we're just saying, hey, it's true, but you would send information like that along that private channel. So with that being said, thank you everyone so much for listening. I hope this was helpful. And if you have literally any questions at all, ask me in the comments. And thank you, Greg, once again. So thanks, everybody. And I'll post all this code on GitHub, including the Excalibur diagram. So thanks, everybody.